Hello students, today is lecture 6 of periodic properties. We have already discussed about the periodic laws, periodic table and SPDF block elements, about the periods, about the groups. Today we will discuss about the periodicity and the trend of some physical properties in the periodic table. So let's start. First is periodicity. We have already discussed about this term periodicity in our previous lectures. So the periodicity is the recurrence of similar properties of the elements after certain regular interval. When they are arranged in the order of increasing atomic number is called the periodicity. That means in periodic table, after certain regular intervals, the properties the properties all the physical properties or chemical properties are get repeated, so that is known as the periodicity. Like if we are talking about the group 1 or alkali metals or group 2 alkaline earth metals, so you can see that the properties are similar for all the alkali metals, as all are present in group 1 and they are coming after a certain interval. So this why this happens in the periodic table? This happens because of the repetition of similar electronic configuration, not completely similar electronic configuration, the electronic configuration of last shell. So the because most of the properties are dependent on the configuration of the last shell, and in periodic table if you observe, you will find that the electronic configuration is repeated after certain interval, and that's why the properties are also repeated after certain interval. And for example, the general electronic configuration of halogen is expressed as Ns2Np5. So it is Ns2Np5. That means the outermost orbital is having 7 number of electrons. This configuration reveals that each of these halogen has a natural tendency to gain 1 electron to acquire stable noble gas configuration, because it is 2 plus 5 7. So if it acquire 1 electron or if it gain 1 electron, then what happen? It will acquire the stable noble gas configuration. That's why all the halogens form halides. Halides, that means X is a representation for the halogens, for all halogens, and a single negative charge. So it readily forms a halide ion because it is having a tendency to gain 1 electron. Clear? Similarly, all the elements which are present in a same group are having similar electronic configuration for the outermost shell. Then trends in physical properties. Physical properties trends, that means as we have discussed earlier, that when the electronic configuration repeated, the properties also repeated. Like if valency, atomic size, ionization, enthalpy, electronegativity. So valency is same for a group, but I'm not saying that atomic size is same for all the elements which are present in a group. But yes, there is some trend in ionization enthalpy, some trend in atomic size, that if we are moving in a group from top to bottom, or moving in a period from left to right, there is some periodicity. The like atomic size, it is having a particular trend that it may be increase or decrease on one particular side. So all the physical properties like valency, atomic size, ionization, enthalpy, electronegativity, etc., are directly related to the electronic configuration of atoms. In physical properties, today we will discuss about the trend of effective nuclear charge and atomic radii. So if we are talking about the effective nuclear charge, first it is important to clear that what is the effective nuclear charge. So effective nuclear charge is basically the charge of nucleus which is felt by the electron present in the atom. So if you are talking about a single electron system, like in case of hydrogen, hydrogen is having only one electron and some positive charge is there in the nucleus of hydrogen. So obviously that positive nucleus attract the electron, and when the electron is attracted by the nucleus, this electron feels some nuclear charge. So this is the effective nuclear charge. But in case of multi-electron atom, what happened? There are some electrons present between the nucleus and external electron, and those electrons also feel some nuclear charge, and the electrons which are present in between the outermost electron and nucleus give some screening effect or shield, so that the actual effective nuclear charge cannot reach to the outer electron. Clear? So each electron in a multi-electron atom experience both attraction to the nucleus and repulsion from interactions with other electron. Because electrons are having negative charge, so electrons repel each other and nucleus attract these electrons. So the presence of multiple electrons decreases the nuclear attraction to some extent. Each electron in a multi-electron atom experience a different magnitude and attraction to the nuclear charge depending on what specific subshell the electron occupies. That means if the electron is present in first shell, obviously it will feel more effective nuclear charge. If it is present in second shell, then some lesser nuclear charge it will feel. And the amount of nuclear charge felt by electron is also depend on the total positive charge present in the nucleus. So overall, the amount of positive charge experienced by any individual electron is the effective nuclear charge. Here this will be more clear with the help of this diagram. This is the example of a 3 electron system, that is lithium. So it is having a 3 positive charge in the nucleus. Clear? It is having 3 positive charge in the nucleus and 2 shells are there, one and second shell. So in first shell 2 electrons are present and these 2 electrons feel a Z effective 2.69. Both are present in similar shells, so obviously the Z effective value for both the inner electrons are same. The electron which is present in second shell, 2s orbital. So what happened here? It is present in 2s orbital. So the Z effective, you can see that Z effective for this 2s electron is lesser as compared to the Z effective for 1s electrons. Why this happens? Because these 2 electrons screen the Z effective. That means this positive charge, this is going to attract this 2s electron, but due to presence of these two, because these two also repel this. So overall the total effective nuclear charge felt by this electron is less as compared to the effective nuclear charge felt by these 2 electrons. Clear? So the shielding effect increases with the number of inner shells of electrons. As the number of inner shells increases, the shielding effect for outer electron is increases and effective nuclear charge of outer electron decreases. If we are talking about the physical property, the effective nuclear charge of outermost electron is important, and mostly it is talking we are talking about the effective nuclear charge for the outermost electron. If it is not mentioned that for which electron we are going to calculate it, so it is for, by default it is for outermost electron. Clear? Also, electrons sharing the same shell do not shield one another from the attractive pull of the nucleus. Like here, these two electrons are present in one s. So both are present in same shell, 1, shell number 1. So these will not repel each other. These will not shield each other. And the effective nuclear charge for both are same. Now, periodic trend and effective nuclear charge. What is the periodic trend for the effective nuclear charge? So here you can see that this one is the periodic table, and in periodic table, when we move from left to right in a period, the effective nuclear charge increases. Why this happens? Because for example, if you're talking about the second period, here lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, etc. So what happened here, that the number of shell remains same. The number of shell is shell 1 and shell 2, clear, because it is in period 2. So there are 2 shells in all the elements which are present in second period, but the number of positive charge increases because the atomic number increases, atomic weight increases, so obviously the positive charge will also increase in the nucleus. And as we have already discussed, that the electron which are present in same shell do not repel each other, okay, do not give shielding effect to each other. So obviously when we move from left to right in a period, the number of positive charge increases, so the positive charge which is felt by the electron or outer electron is same, is increases, clear. So in a period it is increases. Whereas if we go down in a group, what happened when we go down in a group, the number of shells increases. Like hydrogen having 1, lithium is having 2 shells, then sodium 3, potassium 4, etc. So as we move down, the size increases, the number of shell increases, and the distance of outermost electron from the nucleus also increases. And as the shell number of shell increases, the shells which are present between the outermost electron and nucleus, all the electron present in those shells impart shielding effect, and this will subsequently decrease the Z effective value. So in a group, when we move down, the Z effective value decreases, and in a period it increases when we move from left to right. Here some examples are given, like lithium or potassium, which one is having larger Z effective value. So lithium is in second period, potassium is in fourth period. So obviously what happened, obviously the value of Z effective for lithium is more as compared to the potassium, because potassium, in case of potassium, there will be more shielding effect. If we are talking about carbon and oxygen, this is comparison in a period. So what happened, the carbon and oxygen, here the carbon is having lesser Z effective value as compared to the oxygen, because the amount of nuclear charge is more in oxygen as it is having more atomic weight. Then if we are going to compare between carbon and phosphorus, so what happened, carbon and phosphorus, carbon is in second period and phosphorus is in third period. So obviously for phosphorus the screening effect is more, although the positive charge in the nucleus is more in case of phosphorus as compared to the carbon, but shielding effect is also more, and the difference between these two is not much. So the effective nuclear charge for carbon is larger as compared to the phosphorus. Then if we are going to compare for carbon and selenium, so here both are present in p block, and again the carbon, the electron, outermost electron present in carbon is more near to the nucleus as compared to the Se. Then the next one is atomic radius. in case of atomic radius, the next property is atomic radius and periodic trends in atomic radius. So what is the atomic radius? First we will discuss about the atomic radius. The size of atom is very important when we are trying to explain the behavior of atoms or compound, because if the size is smaller, then obviously the effective nuclear charge is higher for the outermost and the attraction for outermost electron is higher. If the size is larger, in that case the outermost electron is far from the nucleus and it is very easy to remove that electron. So the size is very important. And how the size is expressed, because the electron is present in a form of a cloud, so there is not a defined boundaries there. So generally the size of atom is defined by the edge of its orbital, and the atomic radius is defined as the 1/2 the distance between the nuclei of identical atoms that are bonded together. Like if I'm talking about the radii of oxygen, in that case the O2, two atoms of oxygen, so the half of the distance between the nucleus of two oxygen, because the electron is present in the form of cloud, and there is not a defined boundary of the orbital, that is the edge of the orbital, there is not defined boundary. So in a molecule like O2 molecule, the distance between the two oxygen nuclei, and that distance is divided by the 2. This will give the atomic radius for the oxygen. Then if we are talking about the trends for atomic radius in periodic table, what happened? When we move in a period, the value decreases. Why it is decreases? We have already discussed in the effective nuclear charge that when we move in a period from left to right, what happened? The number of shells remains same. That is in second period the number of shell is 2, in third period the number of shell is 3. So in lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, all are having same number of shells. So the size difference is not much. And when we move on right side, what happened? The number of positive charge in the nucleus and number of electrons are increases in the orbitals. So the attraction between the nucleus and these orbitals also increases, which results in a shrinkage in the size of the atom. Whereas when we move down in a group, what happened? The size increases because number of shell increases. Like hydrogen is having only one shell, then lithium is having 2 shells, then sodium is having 3 shells, potassium is having 4 shells. So obviously when the number of shells increases, the size increases more significantly. Clear? So in if we are talking about the atomic radius trend in periodic table, when we move right side in a period, it decreases. When we move down in a group, it increases. It increases in a group because the number of shell increases. It decreases in a period because the number of shell remains same, but the number of positive charge in the nucleus and the number of negative charge in the orbital increases, which attract more, which create a more attractive force, which results a shrinkage in the size of the atom. Clear? So this is the trend for the atomic radius. Here it is also explained again that when we move down a group, what happened? Here you can see that the energy level increases, the number of shells increases. So in a group, when we move down, the number of shells increases and size is also increases. Whereas in a period, what happened? The number of positive charge increases, the number of electron increases, and then attraction between the nuclei and orbital increases, due to which the size is decreasing when we move from left to right. So this is all for today. Today we discussed about the periodicity, periodic trend for the effective nuclear charge and atomic radii. I hope you enjoyed the lecture. We'll meet again. Thank you.